Somebody asked earlier today how the difficulty level of today.
And it's very similar to the difficulty of when we did something like this, where you had x squared times x cubed. How would you simplify that? X to the what? This. Is it hard? No. Does it require a few rules that you need to know? So it's very similar to that, with the exception of we're not putting like a bunch of crud all together. So there is a product property, a quotient property, a power property. They apply to the logs and to the natural logs. Now with all of these ln, mn, they kind of ugly and confusing, but the same rules apply regardless of if it's a regular log or a natural log. You're welcome. So if I take, if I have the log base whatever of anything, and I have two numbers that are being multiplied by each other, I can separate those two as log base b of m plus log base b of n. So you can split them apart. So for example, on part A, how it says log base 4 of 7x, I can rewrite that as the log base 4 of 7 plus the log base 4 of x. You can expand it out.
That is the product property. On your own, try part B.
So you have that 9y. You can expand it out as log base 3 of 9 plus log base 3 of y. Now, do you notice anything that could be simplified in here? The log base 3 of 9. We can rewrite this as what? 3 squared. Is that okay? So what's going to cancel? The log base 3 and the 3 will go away. And our final answer for this one would be 2 plus log base 3 of y. So that might be a reason why you would want to be able to expand them, because you have some simplifying that could happen. Okay. There's also a quotient property. So if I have log base b of m over n plus a fraction, I could separate them as the log base b of m subtract log base b of n. For example, part C, we have that right here. We have kind of two things going on here. The division, you can write it right like this, log of 4x subtract log of y. I got the subtraction because of the quotient. However, is that fully expanded? Could it be expanded more? Could I take this right here and keep going with it? And if we expand this one, log of 4 plus log of x minus log of y.
It's more beneficial to bring it all back in, because soon we will be solving equations. So say that I have this equal to 2y or something. What we're going to have to do is we're going to have to take an expanded equation and shrink it down so that we can solve it. So knowing how to go back and forth will be useful. So there's your way. All right. We can't quite do part D yet because we don't have all of the rules. Yeah, so let's do part D right now. Can we simplify that one? No, because this is a log. If there's no number right here, what's the common log? Remember? It's 10. So yeah, there's no simplifying here. Now what about the power property? The power property says by log base b of m raised to the nth power, this n can come out in front. We'll use that a lot, actually. A lot. It's probably the most important one, actually. We can bring that variable in front, so it's n times the log base b of m. So for this one, part D, for part D, how do we expand it? We've got log base 9 of x to the 4th, plus or minus? Minus log base 9 of 729. I don't know what 729 is, but I'm guessing it might might have something to do with the 9. So, is 9 and a third? Okay. So, a couple things will happen here. Let's take this 4, bring it out front. We've got 4 times log base 9 of x minus, we were told this is 9 to the third. So minus what? Those cancel, minus 3.
How do you feel about it? It looks ugly, yes.
Oh, I love it. No, you're just expanding it. So you want to get it as fully expanded as you can. So I know something is expanded, if there are no more exponents, if there's no multiply here, there's going to be lots of adds and subtracts, and then if you can simplify right here, you need to. So why don't you try, let's see, sometimes trying your own help, try part E, try part F, let's see if you can get it more to expand. E and F. Probably looks a little bit like Chinese we turned on last time. Yeah. Oh, there you go. Okay, so that's the natural log. So there's the day before we learned about the natural numbers that are in the curve. Okay, so you definitely need to so this is the opposite of the natural number. E. Yeah, this one right there. So if I wanted to cancel an E out, this is the natural number. So, it's all about the base. So this thing. So if you have like y equals x squared, you have to find inverse right? And then you just for everything. So if I want to find the inverse of this one, and let's just switch the x and the y, so we'll have like a business here. So we have strategies for everything, right? But not for this one. So the big thing here is I want to get rid of the base 2 or the new log. Okay. So if I want to cancel a base 2 like this, I have to use a log. If I want to cancel a base 3, I have to use a log. So base 4. Now, sometimes or most of the time, I'll have a base right here. If this is log of x, that means the base is 10. This is the common log. So, if I wanted to, that's kind of what we're going with this. There's more in this thing, but well, okay. So this right here is ln. So the natural log and the e, so they're inverse to each other. Kind of like the square to the square root. So those would cancel in the middle. And then the 3, the log base 3 would cancel in the middle. Is that okay? Yeah. Okay. Oh, ish. I'm sorry. Okay, good. So like this one, if I wanted to expand it using the rules we just had, what is it? I don't know, but 4 times x there. This one's just a special name for the natural number. All right, part E, you have this multiplied, so spread it out for me. So, ln4. Oh yeah, that's supposed to be an N. I haven't given points of anything, so if you reserve points, give yourself no more than 3. Yeah. So y'all, I mean, somebody's answer You got 1 point. Somebody point that out. If you did, you got a point for me. Ooh, good question. The log cancels that number. So log, if you have 5 to the x, log base 5 is going to cancel it. If you have a 2 to the x, log base 2 cancels it. Is that okay? So I'm going to use log with just numbers. If you have e to the x, then the natural number cancels it. So that's just what it is. The rules are exactly the same. You could put log base e. They just give it to the phone number. What about part F? This design right here does what? So natural log of e squared plus or minus? Minus natural log of x. And you can simplify here. Ready? So the e and ln go away, so you're left with a 2 minus the natural log of x. Okay? We could, but there's no need to get it to another decimal, so we could. All right, now let's do the reverse. So we want to take it from an expanded logarithm and we want to bring it into a single logarithm. And our goal here is to get us so that we can solve it eventually. So you see on this first one a bunch of adds. This add means what? You reverse it, it's going to be a multiply. So you only need one log. So it's not going to be like the log of 4 times the log of x times the log of y. It's the log of 4 times x times y. On part B, they have to have the same base or it doesn't work. I don't know if you picked up on that. Now it's a subtract, right? So if we bring it into 1, it's going to be log base 4 of what? 32 over 2. Now can you simplify the 32 over 2? So this is log base 4 of what? And can you simplify that? Because 16 is what? 4 squared. And so the log base 4 and the 4 would cancel, and what's our final answer here? 2. That's tricky. Will you try part C on your own? Bring it all into 1. It won't, if you can simplify it, then yes. That's right. So, no, you're good. Nope, you're good. I'm going to sit here and cover while you do first. Perfect. Okay, so what's this next one? Log base 2 of what? So log base 2 of 9 over 3, which is log base 2 of what? Of 3. Does that cancel? No, that is the final answer then. What about part D? Log base 2 of what? 28 over 7, which is the same as log base 2 of 4. But 4 is what? 2 squared. So those cancel. My final answer is 2. Okay, what about this next one? That's tricky. Part E, the natural log of A minus the natural log of B minus the natural log of C. Let's look at just these first two. So the natural log of A over B. Is that okay? Minus the natural log of C. Not really bad, but that's 10%. Yep, you will eventually. So now, this I just hope it's going to help people see how to simplify. Now by rewriting this one, you get the natural log of A over B divided by C, right? How do you simplify that so it's just one fraction? You take the C, you put it over
over 1. You want to get it up here? So this is like this, right? Is that okay? And then how do I divide fractions? We flip and multiply. So we're going to change this to a 1 over c. Change this to a multiply. So my final answer is the natural log of a over b.
Try part F on your own. Oh, sorry, Josh.
I had to add a fourth one to do those, so I can. So part F. So part F, log A plus log B minus log C is going to be log of what? AB over C.
All right, I'm going to pause the recording. Please take, I don't know, 5 to 10, endure through it. It's an endurance question. Okay, let's prove one of these properties.
Okay, so let's look at the power property really quick that says log base b of m to the n power is n times log base b of m. I want to prove, go from here, and prove that this one works. So, hold on. What does log base b of m squared mean? Doesn't that mean log base b of m times m? Is that okay? Same thing, right? Now, can we use the product property above to, can we use the product property above to expand that? Okay. Now, if I had x plus x, how could I rewrite that? 2x, right? If I have log base b of m and log base b of n and I'm adding them together, could I rewrite that as 2 log base b of m?
Does that work? Brandon, I'm gonna use the and so on in this, just for you. Okay, but not quite yet. It's coming.
So let's do the same thing, but what does m cubed mean? Doesn't that mean log base b of m times m times m? Right? So if I were to expand that, what would it be? Why? Log base b of m plus log base b. This is how you do a proof, by the way. Log base, a lot of writing in proof. Okay, so you have to take it from what you know and expand. With the proof,
When you do a proof, you have to do every single little tiny detail. I'm not going to take questions right now. I'm not taking questions right now.
okay, so how would I simplify that? If I have log base b of m, log base b of m, how many of them do I have? 3 log base b of m. So do you kind of see the pattern in why this works, why I can take my power and bring it out front? That's the whole point here. So, okay, now what about this one? How do I prove it for like the general case? This means log base b of m times n times n times dot 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 n, right? We have an unknown amount. Is that okay? Now if I'm doing a formal proof, which by the way,
In high school, I never really did a lot of formal proofs, and it hurt me a little bit when I got to college because I had to learn them for the first time. Granted, you may not go into a field where you have to do a formal proof in college, but some of you might. So let's continue, so maybe that you've at least seen it.
so this dot 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 means, I mean, I can't write an infinite number of n's, right? So we don't know how many there are. There's just a bunch of them. Wouldn't that be the same thing as saying log base b of m plus log base b of m? How many m's do I have? We don't know, so that's where the dot dot dots come in.
We have n amounts of them. So how many do I have? So however many of these there are is your n. No, that's right. We did shorten it. We put dot, dot, dot. You're not going to be asked to prove this on your homework. I was just trying to show you why the exponent can come out front. Okay, so there's more examples. And more examples. Very good. Why don't you try, I'm going to have you do 3 of these. Let's make sure you get it.
Let's try part A right here. Let's try part B right here. Let's try part B. So if you'll do those 3 and if you get them right, then I will assume that we did it. On the top 2, we are expanding. On that bottom one, we are shrinking it back in. I know that you like short homework, so when I ask this question, please understand that I get that the unit left before homework. Do you feel like there's enough problems like this on homework that is totally practice, or do you feel like it's putting your student too much?
I'm just curious. Okay, this is the end of part 1. I could probably just... I ran out of space. It's kind of ugly, but is there anything else you can do here? Is anything canceled? No, so that's it. Okay, what about part B, down below? This time I'm taking something that's expanded and bringing it back in. So I always start by taking the exponents and moving those. So how I move this up, make that y to the 4th, move that up, make that x squared, and then w to the 5th. So where do you suppose we'll start this one? So if you're doing order of operation, you probably should do the parentheses first. Is that okay? So let's do that. 4 minus, or 4 log, this thing, background. This is going to be log of y to the 4th minus, combine those together, log of the x squared w to the 5th. Is that okay? And now combine these two. How do you combine those? Log of y to the 4th over what? X squared w to the 5th? This one. No. This one. Because it came first in the statement. The log y to the 4th came before the minus sign. Because if you think about it, this can be an exponent, so when we were going into what your job is an exponent, you can just apply. Well, what is an exponent in the unit? Because this is on, right? So it would be. Anybody else? Some questions? You okay about those? Okay, we're not there yet. We will be, hold on one second. Actually, why don't we look at 9 and 10 in a minute? You're welcome. 9 and 10 asks you to use the change of base formula to evaluate each expression. I don't know why it tells you that. This is more of a review. So how do you simplify this? Let's try number 9 first. So a review for if you were asked from last time. We'll look at it. What kind of log base 6 of 36? The squares. So we first change this so that the base is 6, so that these eventually will cancel. So log base 6 of 6 cancel. And what do we left with? 2. What about number 10? Is 64 a perfect 4? 4 to the? Okay. Is it a perfect 4 though? So this is 4 to the third. And if I want to bring it so it's no longer in the denominator, it would be what? 4 to the negative 3. So now you have log base 4 and you have 4. They will cancel. And what are you left with? However, what do you do if you can't rewrite it so they cancel? Sometimes you have found it in your calculator. You plug it in. If you don't have that button on your calculator, let me show you what to do. So head back to the notes for just a second. I don't know. I didn't do that. I don't know where it is. If you figure it out, we're going to call that a fantastic. If not, this is how you do it. This is called the change of base formula. If I have log, and you really can't ignore this C right here. Okay. If I have log base B of M and I want to evaluate them in my calculator, that is the same thing as saying the log of M divided by the log of B. You can plug that into your calculator and do that. So for part A over here, if I wanted to plug this into my calculator, I would say log of 27 divided by the log of 81. Plug that into your calculator and you get. This one is 9 and 10 on the homework. Look at this one for. What did you get it? Okay. So how would you plug part B into your calculator if you had to use a change of base formula? It would be log of what? 6 over 5 is what? Do you feel like I need to keep giving you examples, or are you okay with it? Part B is what? Log of 16 over log 4. What did we do here? So yeah, clearly this is going to be a calculator question, right? That's a third. Just don't run it. Never mind. And that's the end. So the rest of your homework does that. It should end really quickly. I need to come around and get your day 1, 2, and 3 homework scores.
What number was B 2.2?
What?
It was 2.2.
I'm not sure. I'll pull it back up for you though. Part B was 2.23 is what I got, but.
So for day 1.
Thanks for watching. Peace out.